We're going to be graphing this polynomial by identifying some key characteristics like its roots, the multiplicity on the roots, the behavior, whether they cross off the x-axis. Then we'll look at the end behavior by looking at the degree of the entire polynomial and its leading coefficient. So to find the x-intercepts, you have to set it equal to 0 and decide on a plan in order to find those x-intercepts. I'm going to factor this because I noticed that there is a common factor. 3 divides all three terms and they share an x. So 3x times x squared gets me back to 3x to the third, minus 3x times 4x gets me back to 12x squared, minus 3x times 5 gets me back to 15x. Now I notice that the inside trinomial is in the form x squared x and a constant. So I'm going to see if I could factor that by using the graphic organizer and saying what multiplies to the back number, -5, and adds to the middle number, -4. So the factor pair would be -5 and 1, because -5 times 1 is -5, and -5 plus 1 is -4. So my final factored form here, x squared splits as x and x, and my two factors are -5 and +1. So looks like I have 3 factors here total, and in order to find the roots, I'm going to start filling in this chart here. To find the roots, you set each of those equal to 0. So if I set 3x equal to 0, I would get 0. The multiplicity is the exponent that it's raised to. It's raised to the first power. So the multiplicity is 1, and because that's an odd number, it's going to cross the x-axis. The next factor, if I set this equal to 0, really all you have to do is flip this sign, so it becomes +5. The multiplicity is 1 because it's to the first power, and since it's odd, it's going to cross the x-axis. Lastly, if I set this final factor equal to 0 or flip that sign, it becomes -1. It's to the first power again, so the multiplicity is 1, and because it's odd, just like the previous two, it's going to cross the x-axis. So what is the degree of this polynomial? The degree is to the third power here, and the leading coefficient is positive. I'm looking at the sign, so it's a positive value. So the end behavior of degree 3 with a positive coefficient looks like this: down to the left side and an arrow pointing up on the right side. So let's go ahead and graph this. So my roots are at 0, 5, and -1. Okay, so the end behavior, arrow pointing down on the left side, arrow pointing up on the right side. So at -1, it's going to cross. Then at 0, it's going to cross, and at 5, it's going to cross. And again, I don't know how high or how low it goes at these points right here. We're just doing a quick sketch. And the end behavior, I do want to write that more formally. So we're saying as x approaches infinity, so as x is getting larger, it's rising, right? So your y values are getting larger as well. So as x approaches infinity, f of x, which is the same thing as y, is also going to infinity. And as x approaches -infinity, let's check out what happens on the left side. As x is getting smaller, it's decreasing here, right? So the y values are going to -infinity. So as x approaches -infinity, the y values are also approaching -infinity. So that would be your end behavior.